Hi, you're right. Today we're going to look at a quick way to convert between fractions and decimals using what we know about place value. And what this method relies on is being able to scale a fraction so that it is over 10 as the denominator or over 100 as a denominator. So let's just have a quick look at the place value table, or just part of it, to see why this works. Now, if we had a fraction like 3/10, for example, it kind of relies on us knowing that this column to the right of the decimal point is the tenths column. So if we've got 3/10, we literally just have 3 in the tenths column, and we don't have any ones or units, as you may know them. So our decimal is 0.3. And that's a very quick way to convert a fraction to a decimal. Okay. If we had a slightly harder one though, let's say something like 4/50ths, we can't scale that easily into a number over 10. So I'd have to divide by 5 there, and as you can see, I can't really divide by 5 and get an integer here. So the other thing we could do is, instead of scaling it so that it's over 10, we could scale it so that it's over 100, which this one would do quite nicely. I've got to multiply by 2 there. If I multiply this by 2, I get 8. And there I've got 8 hundredths. And the hundredths column is the next one to the right, so I've got 8 in there. I don't have any tenths, and I don't have any ones or units, so my decimal is 0.08. Okay, so we're always looking to see whether we can turn the denominator into 10 or 100. And this method carries on actually beyond that, and you've just got to think about what these columns would be called. The next one would be thousandths, and then 10,000ths, and they kind of match the names of the columns to the left of the decimal point. So to be able to do this, to be able to tell whether something can be scaled into 10 or 100 easily, we should probably know the factors of those numbers, and the harder one of those is 100. So let's go for the factors of 100. Always list factors in pairs, it's much easier. So 1 and 100. What times 2 make 100? 2 and 50. 3 won't go into it. 4 will. 4 times 25. 5 times 20. 6 won't. 7 won't. 8 won't. 9 won't. And 10 will. 10 times 10. So I'm just going to list 10 once. So if you want those in ascending order, 1, 2, 4, 5, 10, 20, 25, 50 and 100. Okay, let's have a look at the questions on this page then. Maybe pause and have a go first, and then just use this to check your answers. So 1/2, can it be scaled? Well, actually, the 2 could turn into a 10 or 100. I'm going to go with 10. So yes, because 2 is a factor of 10. If we multiply by 5, it would turn into 10. So I'd need to multiply the numerator by 5 as well. So that would be 5/10. But also we could turn it into hundredths. Anything that will turn into tenths will also turn into hundredths anyway, by the way. So to turn it into 100, instead of multiplying by 5, I would multiply by 50. So the numerator by 50 would be 50 over 100. Okay, so the decimal equivalent, if I use this one, is 0.5. In other words, 5 in the tenths column. 1/3 is 3 is neither a factor of 10 nor a factor of 100. So can it be scaled? For the purposes of this, no. Okay, the equivalent decimal for 1/3, you may just know, is 0.3 recurring. So this is not the only way to convert a fraction to a decimal. It's a very efficient way using our knowledge of place value, but it's not the only way. I'll show you how we got that answer in a second. 2/5. 5 can turn into 10. Doesn't really matter what the top number is. And 5 can also turn into 100. So yes. To turn it into a 10, I would double it. So I need to double the top number. To turn it into 100, I would times by 20. 2 times 20 is 40. The decimal equivalent is 0.4. 22 over 50, well, it won't turn into 10, but it will turn into 100. And to do that, I would have to double it, double the numerator, and we get 44. So this would be 0.44. So in other words, I've got 44 in the hundredths, or I could say I've got 4 in the tenths and 4 in the hundredths. 1/4. 4 was a factor of 100, so yes, it can be scaled. It 4 won't go into tenths, but it will go into hundredths. And to do that, we'd multiply by 25. 1 lot of 25 is 25, so the answer is 0.25. 2/7. 7 is not a factor of 10 nor a factor of 100, so no. And I'll come back to show you how to work out the decimal for that one in a second. Do all those ones at the end. 3/20. Yes, 20 will go into 100. It's a factor of 100. We times by 5 to turn it into 100. So if we times 3 by 5, we get 15. So that's 0.15. 25ths will go into 100 times by 4. Multiply 2 by 4, we get 8. So this is 0.08. 30 will not multiply by something to go into 100. I could divide by 3 to turn it into 10, but I can't divide this by 3, so for the purposes of this, no. 3/4, 4 will go into 100. As we said earlier, we multiplied by 25, so 3 lots of 25 are 75, so 0.75. You may have just recognised that one anyway. 8 will not go into 10, and it also won't go into 100, so no. I'll just put a little star with that one because it will go into 1,000. So you can actually use this method with it. I'll come back to that one at the end, I'll show you. And the final one, 5/25. 25 will go into 100 by multiplying by 4. 4 lots of 5 are 20. Now, the answer there is 20 hundredths, but I can cancel that down by knocking off those zeros, and that will give me 2/10, which is 0.2. More efficient way than writing 0.20, which is what this one would lead to. Okay, let's show you how to do those other ones. So the ones that can't be scaled can still be turned into decimals. We just can't write an equivalent fraction over 10 or 100. The other way to convert a fraction to a decimal is to simply complete the division that this fraction is showing. A fraction shows a division. This is 2 being divided into 7. So 2 divided by 7. So if I use the bus stop method for that, the number we're dividing is there, by the way. Oh, wait, I'll do this on the third one actually. So this is 1 being divided by 3. So how many 3's go into 1? 0. So we need to put a decimal point. I'm going to move the 1 to there. Now I didn't have anything to put it next to, so I added a 0. Nothing wrong with writing 1 as 1.0. Now that 1 is there though. How many 3's go into 10? 3, with 1 remaining. Nothing to put it next to again, so I add a 0. How many 3's go into 10? 3, with 1 remaining. And you get the idea, you get where this is going. It's going to keep going like that forever, and therefore we can put a recurring dot above the recurring digit of a 3 and say that our answer is just 0.3 recurring. Okay, let's have a look at 2/7. This is 2 being divided into 7. I'm just going to use this space actually. So decimal point, because no 7's will go into 2. We put a 0 there. Decimal points here and here. Carry my 2. Nothing to put it next to, so I'm going to put a 0. How many 7's go into 20? 2 7's are 14, so there's 6 remaining. Put a 0 every time we don't have anything next to it. How many 7's go into 60? 7 8's are 56, so 8. 4 remaining. How many 7's go into 40? 5. 5 7's are 35. 5 remaining. 7's into 50 goes 7 times, so that's 49. 1 remaining. 7's into 10 goes once, with 3 remaining. 7's into 30 goes 4 times, with 2 remaining. Mine's getting longer. 7's into 20. Now we've already seen that here. That goes twice with 6 remaining, and you can see that we're going to get, at this point here, we're going to get the same pattern that we got here. Okay, so it's going to recur again. However, the recurring pattern is not just 1 digit this time, it's actually 6 digits we're going to keep getting. So it's going to recur across the 2 all the way to the 4. Okay, and to show that, we just put a dot above the start and the end of the recurring pattern. Don't need to show this final 2. Okay, so that's our answer there. 0.285714 recurring, that pattern. Okay, sometimes you'll see it with a bar across the ones that recur, but most of the time in this country we show it like this. Okay, 7/30, so we're dividing 7 into 30. How many 30s go into 7? None, it's too big. Put the 7 there. How many 7s go into, 30s go into 70? 2 with 10 remaining. How many 30s go into 100? 3 with 10 remaining. And you can see at this point we're going to keep getting 3. Okay, so this is 0.23 with the 3 recurring. Okay, notice I haven't put a dot above the 2 because the 2 just is the first digit after the decimal point, but then it's just going to be 3s from then onwards. Now 7/8, I said, won't scale into 10 or 100, but it will go into 1,000. 8 is a factor of 1,000. So it's, to find out how many times it goes into 1,000, we could do 1,000 divided by 8. Just do that over here. Just cancel that down a little bit. That is, if I halve both those numbers, that's 500 divided by 4. Halve those again. 250 divided by 2. And we're at a point now where I think you can spot that the answer will be 125. Okay, so I've multiplied by 125 to get 1,000. So if I multiply that by 125, that's 125 less than 1,000, 875. And we can do this a similar way to how we've done tenths and hundredths, because the next column in the place value table would be thousandths. So if I've got 875 thousandths, then I've got 0.875. Okay, hopefully that made sense. If not, there are plenty of videos out there on YouTube for how to do this. Okay, next page will be on the next video. Thanks for watching, guys.